Hello, my name is Antonio Bendito. I'm doing a project with academic advisor Mr. Daniel. The project is called Procedural Game Generation. We have to know two things. First, gameplay is the way that the players interact with the game. Second, procedural generation is the use of math and algorithms to create data. So our problem is that the use of procedural generation in generating gameplay is lacking. A lot of games use procedural generation in some way. For example, generating sounds. But we are yet to find games that use the procedural generation of gameplay. So our solution is that we made a game that focuses on the procedural generation of gameplay, specifically generating goals. The genre of the game is a 2D platformer which uses multiplayer. Gameplay in our case is not tailor-made, so we decided that the game will be on the chaotic side. We faced a few challenges. First is that the documentation that we found doesn't suit our needs, and the available resources rely on ready-made content. Second is that we need to keep the procedural content that we generated up to date on all clients, which can be on different PCs on the internet. Second, we have to build other parts of the game. These parts are not procedural. For example, the sound, visual effects, UI elements, and more. So our plan was to first procedurally generate the rules, then based on these rules we generate the map, then based on the map and rules we generate the goals. And at the same time we make a game that utilizes those features. We generate various rules in our game. For example, we generate the gravity type, the gravity strength, the map length, jump height, player speed, and time limit. Map generation. In order to generate the map, we first need some predefined platform objects. Example is on the bottom left. We join these together in order to make a map. After we finish, we might apply a circular transformation in order to get a globe map instead of flat one. After we finish, we synchronize the map across the clients. Goals. We make goals into two steps. First, we manually create atomic goals. These goals can be like to race to the end of the map, touch a specific player, or defeat the boss. We use compound goals in order to give the atomic goals that we made more variety. The algorithm is that we first pick two compatible atomic goals. Then there is a chance that we might apply a not relation to them. After that, we combine them using an AND or an OR relation. These are some examples of generated goals. Pause the video if you want to read them. In this example, the player can choose to race or to touch player 5. But because he lost both of them, he loses the whole quest. In this example, the player can choose between helping in collecting candy or killing the entities. So the player collected the required amount of candy, and now he is trying to prevent the other players from completing the second part, which makes him win this round. Here are more examples to generated goals. These goals use the same system as the game itself. Thank you for watching until the end. Hope you have a nice day.